Uh, where is yesterday? I could not take the class, and I could not communicate it to Srabha also. But Srabha, don't phone 3-4 times. If first time I am not answering means I am busy. Okay? So
Yes.
today we will only solve problems, and no. Okay, some amount of theory will enter there, but we will only solve problems today. Can we direct? You have a calculator, all of you? Do you have the printout of problem sheet that I have given? I have already given a 2-page, I think that is the latest problem sheet. दिया कि नहीं दिया? See, everything cannot be in mobile. Although it is online teaching, it doesn't mean that everything should be online. You must have a printout of important things. For example, all formula. You should write down in your notebook all important formula, because now I'm asking you to solve problem. You cannot go back to your computer. All important formula you should write down in your notebook, and problem sheet you should keep a printout. How to take the printout, that you see. So किसी के पास प्रिंट आउट लिया हुआ है प्रॉब्लम सीट? ओके, चलो नहीं है. कैन यू ओपन इट इन योर मोबाइल और लैपटॉप?
Yes, sir.
कितना प्रॉब्लम है टोटल?
17.
17. चलो. So okay. Let me tell you one thing. We are meeting after almost 1 week. Is that clear? I'm not happy that you requested me for such a long gap. I'm not happy. But still I agreed that during Onam or during Bihu or during all this thing, you need such a big gap. I'm not happy. If you look for a gap, institute can give you a gap of 1 full year before you get your degree. I'm not happy with such a long gap. So anyway, so in future, never request me for such a long gap. I can consider 1 day, लेकिन whole weekend you requested for a gap. तो चलो अभी चालू करो प्रॉब्लम सॉल्विंग. आज हम सिर्फ प्रॉब्लम सॉल्विंग करेंगे. प्रॉब्लम नंबर 1, आंसर मुझे चाहिए 3 मिनट के अंदर. योर टाइम स्टार्ट्स नाउ. प्रॉब्लम नंबर 1. In case you have a doubt, you can directly ask me. This is not exam. You can ask me if you have a doubt. If you cannot solve, you ask me. Question number 1. Let me give you a hint. What is the equation here? सबसे पहले equation लिखना पड़ेगा. What is the equation? Can anybody tell me? Your first line should be the equation. What is the equation? Is it mx double dot? Nobody is answering. What is the equation here? Can anybody tell me?
K theta double dot plus K theta equal to 0.
नहीं श्रद्धा थोड़ा साइलेंट रहो. क्लास में और भी स्टूडेंट है. नंदना.
J theta double dot plus C theta plus KT is equals to 0.
C theta dot. Damping has to be multiplied with velocity, angular velocity, theta dot plus kt. K, you can write K also, but this K is not our linear stiffness. This is angular stiffness, torque per unit angle. You can write K also. K theta is equal to 0. Fine. So now you proceed. You find out zeta first, damping factor first. And from damping, and then you find out omega n. I'm giving you a hint. If you can find out damping factor and omega n, you can find out J and C. So you have to find out J and C. K दिया हुआ है. नहीं, sorry. J is given. K निकालना पड़े. J is given. J is mr square by 2. J is mr square by 2. So J is given. Torsional stiffness K निकालना पड़ेगा from omega n. Omega n is square root of torsional stiffness divided by J. Let me repeat again. Omega n is square root of torsional stiffness divided by moment of inertia J. J is mr square by 2. So in this case, radius of gyration, so directly mk square. No mr square by 2 because radius of gyration is given. So mass into radius of gyration square will give you mass moment of inertia. And logarithmic decrement is ln x1 by x2 mat likho. It will be theta 1 by theta 2. Logarithmic decrement is ln theta 1 by theta 2. Don't write x1 by x2. Theta 1 is 20 degree, theta 2 is 1.6 degree. So this will give you damping factor. How much you got damping factor? Sorry, class में
0.373.
0.035.
Richa saying 2.03. और कौन बोला अभी?
0.03.
0.03 damping
Yes.
factor.
Yes.
Okay. Is it matching with others?
So mine is 0.373.
Damping cannot be minus.
No, sorry, it's 0.373.
0.373, Richa saying 0.03. Both answer cannot be correct. I haven't done it because this was such an easy question that I haven't solved myself. Shrabha कितना आ रहा?
Sir, I am
Damping
also getting
factor.
0.373.
0.373. Richa, then you check it. If your logarithmic decrement is ln 20 by 1.6. And logarithmic decrement is 2 pi zeta upon square root of 1 minus zeta square.
Yes, sir, I made a mistake. I didn't see
Okay,
1.6.
take it.
I
So if you
thought
have got damping, next what you would do? What is 3 seconds, what does it mean? After
So
a
6
gap of
seconds is time period.
6 seconds, what does it mean? This information, how does it help us?
That is the time period of one oscillation.
No, that is the damn time period.
Okay.
So 2 pi by 6 will give us not natural frequency, it will give us omega d, damn natural frequency. So 2 pi by 6 will give us damn natural frequency omega d, and we know omega d is omega n into square root of 1 minus zeta square. So we can find out natural frequency here, and the natural frequency is square root of torsional stiffness by J. We can find out torsional stiffness from there. You are taking 10 minutes for 3 minutes problem. First you find out damping factor, which will be roughly 0.373, something like that. Then you find out damn time period. From damn time period you find out damn natural frequency. Damn time period is 6 seconds. So 2 pi divided by 6 will give you damped natural frequency omega d. Omega d is omega n into 1 minus square root 1 minus zeta square. So you can find out omega n. Omega n is equal to square root torsional stiffness by J. You know J, mk square. So you can find out torsional stiffness. Unit of torsional stiffness will be Newton meter per radian. Unit of torsional stiffness will be Newton meter per radian.
So I got my natural frequency as 1.12.
No, as
radians per
I said, I don't have, I haven't solved, so I cannot say whether you have done it correctly or not. But let's go to problem number 2. I think rest part you can do. Rest you can do. So let's go to problem number 2. All of you read the problem number 2, and then you first discuss how you think you can solve it. Don't jump into solving it. I'll give you enough time. Problem number 2, I'll give you 10 minutes. So first you read it and then decide how you will proceed to solve it. First to make a strategy. All of you switch over to problem number 2, even if you have not finished problem number 1. You can finish it later on. But all of you read question number 2 and tell me, how do you think you can solve it? Now, first you have to discuss with me. I'm waiting. I mean, I'm not in a hurry. I'm not in a hurry, but you just think if you can solve the problem.
So when the question says that maximum vibration of 2 mm is measured at 25
Question
hertz,
says, I don't want to learn from you. How will you proceed?
So actually, I had a question there, Ki, like what does that
You had a
first line mean?
question. Okay. So, okay. Let me hear your question. Beneath.
So when the question says maximum vibration of 2 mm is measured at 25 hertz, like does the question mean that 25 hertz is where the resonance is occurring and 22 mm is hence the maximum amplitude because of resonance?
Okay. Yeah, it's a very good question. The answer is yes, but provided damping is small. No, listen. Provided damping is small, but we don't know how much is damping. Agree? What we do is we assume damping is small. And if you have remembered, I had given what is the limit I had given? During my lecture, I have told that if damping is less than this, then this assumption is more or less acceptable. Do you remember what value I had given?
Less than
Little less
0.2.
than 0.2.
10.2.
0.2.
0.2, sir.
0.2, correct. So what you do is you proceed with the assumption, and then if you find that damping is coming out to be less than 0.2, that means you are correct in that assumption. Otherwise, you have to cancel. But you start with that assumption because you can use simpler formula. So initially you say, let us assume damping is small, and then you proceed using the simpler formula. लेकिन एक बार चेक करना पड़ेगा damping really small है कि नहीं. हाँ, चलो. So all of you proceed with the assumption that damping is small, which means omega n is approximately 20, and the peak value is xs into 1 upon 2 zeta. Peak value is xs, static deflection, multiplied by 1 upon 2 zeta. All these small formula I had given, you should also write it down on a single page. Even in exam also, it will save time. So first you assume damping is small, so that frequency is approximately equal to or equal to 25 hertz. 25 hertz मतलब रेडियन पर सेकेंड में कन्वर्ट करना होगा. 157 रेडियन per second. And then peak amplitude is equal to static deflection multiplied by 1 upon 2 zeta. So I am showing my solution, but you do it yourself. I'm showing my solution, but you need not look at my solution. If you know how to proceed, you proceed, because it will give you confidence. On the screen, you can see my approach also, but do all the calculation yourself. Don't borrow the calculation from my answers. You can only see how the problem has been attacked. You may have a different concept also. If you have another thinking, let me know. A problem can be solved using different approach as well. Anyone who has completed and he is getting different answer or same answer, let me know. But do all the calculation yourself. You need large practice. Otherwise, in exam, time management will be difficult. You are so fast on your mobile, but you cannot solve the problem quickly. Huh? इतना टाइम क्यों लगेगा?
Sir, same answer.
No, but only Srabha. But what about others? See, time is also a big factor. You have to be quick with your calculator.
Sir, same answer.
Same answer. Okay.
Yes, sir.
So, no, fine. Now, please remember that we started with damping small. So, how much damping came out to be? So, yes, damping came out to be 0.0108. So, this assumption is valid. But in case damping is much higher, we cannot start in this manner. Then the problem becomes far more complicated. It can still be solved, but in exam generally I will not ask those complicated problems. So you please remember that we can assume, but that assumption is to be cross-checked. Okay? So let us go to problem number 5.
Sir,
हाँ बोलो
sir, I have a doubt.
बोलो definitely you can ask. हाँ
Sir, we are assuming damping, right? So, how can 25 hertz be natural frequency? It can be damped frequency also.
you calculate your damn natural, that is damn natural frequency, agree, but are they very much different or almost same?
Almost same because
Yeah, so that is the thing. So that is the thing. So that's what we have assumed. So there will be some error. There will be some error. Definitely my natural frequency is not 25. Natural frequency is little more than 25. But error is very, very small because damping is small. Damping is 0.01 means very, very small damping.
yes.
Chalo, let's go to question number 5.
Sir, I have another doubt.
Bolo, you can ask doubt.
Why can't we do the ln formula in this? Because we have been given two amplitudes.
This is forced vibration.
Find the
This is not.
decrement.
This is forced vibration. This is not free vibration. Logarithmic decrement is valid for free vibration under damped.
So won't the graph be same for underdamped forced
Definitely not.
vibration?
Definitely not. And that is why I am looking forward for a MATLAB programming. Okay.
Okay.
कितने लोगों को MATLAB लोड हो गया कंप्यूटर में? नाम बताओ धीरे धीरे.
हाँ सर.
नाम बोलो. साहिल का हो गया, ठीक है. और एमटेक का है मालूम है. बाकी बीटेक के लोग और कितना टाइम लोगे?
और या
हो गया ऐसा.
दिवाकर.
हो गया? Sai Krishna. Sahil?
और या
Okay, that means okay. No. So because I really want to come to MATLAB simulation, it will make your understanding far better. Anyway, so Richa had a question. Why can't you use logarithmic decrement formula here? Because two amplitudes are given. There is a fundamental difference. One difference is that logarithmic decrement is used for free vibration. This is not free vibration. You look at the question number 2. Is excited by a harmonic force. So it is forced vibration. Second is these two magnitudes are occurring not at two different instant of time. these two magnitudes are occurring for two different excitation frequency. So that's why I'm saying that exactly this is the reason why I'm saying that this is just the beginning, and we have discussed some 6-7 formulas so far. In exam, you will get confused, so you write down neatly on a single page. This is free vibration formula. This is forced vibration formula. Everything you must have a neatly written formula sheet with you when you appear for exam. Otherwise, you will get confused. My question is forced vibration, you will use free vibration formula. है So you neatly write down that these are the formula for free vibration, these are the formula for forced vibration, and okay, आगे जो आएगा neatly. Any other question from anybody? So let us go to question number 5. And this, I think, without my hint, you can do it. Question number 5. Question number 5 is similar problem. Only thing, similar problem and exact natural frequency amplitude is given. So at natural frequency, the amplitude is 0.05. So there is no confusion. It is static displacement multiplied by 1/2 zeta. No assumption is needed here. So 5 centimeter is static deflection multiplied by 1/2 zeta. Because omega n is exactly equal to omega is equal to omega n, r is 1, so this becomes 0. Otherwise, problem is similar. Problem is similar. But let me see how long you take to solve the problem.
Sir,
हाँ बोलो
0.06.
अरे answer. Okay. Let me see. I don't know. Oh, I haven't calculated. But yes, procedure remains same. 0.03. Fine. But here, remember, here in this question, you don't require the assumption, and therefore you don't need to cross-check in this question, because amplitude has been given exactly at natural frequency. So procedure remains same. Your answers, I think you can do it. Now, is the question, go to question number 4. All of you, we have to solve 2 more problems, which are bigger problems. So go to question number 4. Go to question number 4. It will take time, half an hour. I will not give you half an hour, but at least 5 minutes I'll give you for reading the problem. Question number 4. I just want one comment from you. What do you think? This is very easy problem or this is a tough problem? कैसा लग रहा? रिचा?
हो जाएगा आई थिंक.
हो जाएगा तो कोशिश करो. गुड 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 हो जाएगा. Where is my MTech friends? Prasad, can you do it?
Yes, sir.
Everybody
Yes,
is yes, sir. Okay, fine. So I will discuss something, then I will leave it up to you. I'll discuss something. A very interesting thing I'll discuss, then I will leave it up to you. Arey. Okay. Yeah. Look at this derivation. Just read it. Just read it. Look at this derivation. Just read it. I'll give you the PPT. Read it and and tell me. Note. First, you look at the derivation. What is interesting thing in this particular question number 4 is a case. It belongs to a particular situation where excitation force is resulting from rotating unbalance. And my undergraduate students, please, you may still remember that in theory of machine 2, it has been discussed how to handle rotating unbalance. And now we see the damaging aspect of rotating unbalance. However, so whenever the excitation force comes from rotating unbalance, our problem is little more complicated. Why? Because of this numerator, gentleman. Because R is a variable. So R not only appears in the denominator. Denominator is my dynamic amplification factor, same as that. But I have another term in the numerator. So that is how this situation is not same as forced. It is a forced vibration, but a special type of forced vibration. So here the interesting thing is why it is a special type of forced vibration, because as omega increases, F0 also increases. In my earlier discussions, amplitude of excitation was fixed. It was constant. But in case of rotating unbalance, amplitude of excitation will also change with running speed. Not only dynamic amplification factor will change, even amplitude of excitation will also change with omega. So this situation is slightly different, and if we can plot it as a function of R and damping zeta, we get a graph. So this is the graph we get. This is not same as our dynamic amplification factor graph. This is the graph. Capital M, mass of the machine. Capital X, vibration amplitude of the machine. And ME is the amount of unbalance. ME is amount of unbalance. Amount of unbalance is always written as a product of mass and eccentricity. So this is amount of unbalance, ME. and numerator mass of the machine and vibration amplitude of the machine. So this ratio, if it is large, it means situation is bad. So looking at this graph and reading problem number 4, what do you think? Any comment, any suggestion? Look at the graph and read the problem number 4 again and tell me, what do you think?
So since the system is undamped, I think
It is undamped.
so we know which graph we are looking at in this question, like which exact plot curve we are looking at.
Okay, fine. Okay, fine. So many graphs not needed. That's fine. But after that,
Sir, since omega equals to omega n, when the unbalanced force
who
will
says?
be,
No, who says omega is equal to omega n? In the question, it is nowhere mentioned.
No, sir.
Nowhere
By
it is
looking at
mentioned.
by looking at graph, we can
No,
see that
question is
almost
no,
yes, sir.
no. You look at the graph without looking at the question. Look at the graph. First, try to understand the graph because this graph is different from dynamic amplification graph. And then you read the question and I need a comment how to solve the question. How this graph will help us to solve this question. You have to study the graph, you have to read the question both carefully. And then you tell me, yes, this graph helps me to solve question number 4. How? How it will help you, that you have to tell me.
So since it's given that the rotating speed will be between 300 and 600 RPM, and so like we can assume that that entire the entire band of angular speeds 300 to 600 will lie on either either one side of the peak in the graph. So like we can have an understanding
Okay. Either one side matlab
like either on the left hand side or on the right hand side of
left
the
hand
peak.
side or right hand side. Okay, you mean to say either it will be closer to the y-axis or far away from y-axis. That is what you are trying to say.
Yes, sir.
Anyone else? एक किस कौन बोला ये? नाम क्या है?
Vineet.
Vinit.
Yes, sir.
अच्छा, let me hear from others. If you look at the graph, you get a very interesting engineering observation. Question number 4 is slightly difficult. I agree. It is not an ordinary question, but you have to understand the graph. The graph will give you the hint what you have to do. The graph will give you the hint. So read the question and look at the graph. And then you tell me, this is how I will proceed. Anybody? Beneath has said something. What about others? Agree, but what will happen if we go far away from y-axis? Then also vibration decreases, isn't it? If I go too far away from y-axis, then also vibration decreases.
Sir, for y-axis we have boundary value. We have given ME, or X is also given that it is less than 3 mm. We can take 3 mm and find the value of R for which.
Right. Y value कितना आ रहा? All of you calculate the y value as per the problem. As per the problem. What is the y value?
.96.
So it is a very, very important finding. So how do you look at it? इसका मतलब क्या है?
Resonance.
अरे नहीं. Y
Sir.
value 0.96. Speed ratio, frequency ratio is not 0.96.
Sir, at 0.96, we'll draw a horizontal line, and wherever it cuts the graph at 2 points, there we know that there will be, we'll getting two ratios.
Agree. But can you further say what do you mean by that? I mean, what your findings are? How it is going to help you?
Sir, that two ranges or two frequency ratios, what we will get, we will have to be on the outer side of the two, not on the inside.
I agree. I fully agree. What you are saying is that is a general comment, but in this question, how it is going to help? Okay, let me explain. All of you very critically listen. In this side, that is, it is called high frequency zone because excitation frequency is much greater than 1. In this side, my vibration amplitude decreases, but it doesn't fall below 1. So what is the minimum value that I can achieve? If I go for a large value of frequency, definitely vibration decreases. But it decreases up to 1, not below 1. Not below 1. And how much value I am getting in my problem? Is it 1 or less than 1?
Sir, less than 1.
Less than
0.96.
1. That means I cannot operate in this region. No. If I operate in this region, I can never get my amplitude 3 mm. No. So my operating region has to be somewhere here. Agree? My operating region has to be somewhere here. This is the basic concept. So what you do is, as you pointed out, you draw a horizontal line 0.96. Wherever it intersects, that should correspond to 600 RPM. Because 300 RPM will anyway be on the left hand side and vibration amplitude will be far less. So wherever 0.969 intersects with 600 RPM, wherever it intersects, that frequency should correspond to 600 RPM. Then automatically 300 RPM, the vibration amplitude will be less than 0.96. So this is the hint. Now you proceed. So you got the hint that wherever 0.969 becomes equal to the value. Now, what is this value? The value is given by this formula. कहाँ गया? अरे. Yeah. Value is given by this formula. So you have to find out R. Damping नहीं है. So you have to find out R. So this R you have to calculate with respect to 600 RPM. तो यहाँ से ओमेगा एन मिलेगा. निकालो. Now you do. Now you can solve the problem quickly. So I'm giving you a hint. I think I'll give you the PPT also. Let us go to anybody now. Let us go to another problem. But before we shift to another question, do you think you can solve it now, or you still find some difficulty? I have given you enough hint. Do you think the hint is good enough, or
Yes, sir, we can find it.
you can find it? Okay. So let us go to question number 3. Question number 3. Problem number 3. Let us go to problem number 3. उसको पढ़ो. This is the last problem we will discuss. Problem
Sir.
number 3. हाँ बोलो.
Doubt in the previous question.
हाँ बोलो. Graph.
Yes, sir.
हाँ बोलो.
So why did we assume that the 3 mm will correspond to 600 RPM?
No. What I am saying, see, this point is this point 969 will intersect at some R. Agree?
Yes, sir. Yes, sir.
Now that R suppose comes out to be 0.8.
Yes, sir.
Now this R is the maximum R. My machine cannot exceed R greater than 0.8, because the moment R is greater than 0.8, the vibration amplitude goes above 0.969. This ratio goes above 0.969. So my machine cannot exceed R greater than this particular value. Agree?
Yes, sir.
Now, at 300 RPM, it will exceed, or at 600 RPM, it will exceed.
So I was thinking, what if the entire range lies way below
Yeah,
this
that is
limiting
exactly what I'm saying. If this is for 600 RPM, 300 will be here. This
So, but if
side.
it is for 800 RPM, then both 600 and 300 will be there. So how do we know?
Oh, no. But machine is not going up to 800 RPM.
So we have to assume that we have to work with the limiting, only at the limiting.
No. It is written in the question that machine speed varies between 300 to 600.
So the entire region can be way less than 300, right? It doesn't have to mean that 3 mm. It doesn't have to mean that 600 should correspond to 3.
No. Let me tell you, if I can further make it this side, it is better.
Yes, sir.
I agree. That I agree. It means, this graph finally means my operating region should be somewhere here,
Yes, sir.
because my vibration amplitude is very, very small. But operating region somewhere here means my excitation frequency is very, very small. So machine RPM also become very, very small.
Yes, sir.
Now, with that small RPM, my machine is supposed to do some work. It may not do that work. See, suppose it is a ceiling fan. By the by, रिचा, घर का सीलिंग फैन का आरपीएम कितना होता?
I don't know, sir.
You are studying mechanical engineering or computer science?
Mechanical.
Then, have I asked something very unconnected question? Okay. Can you tell me in your house which application has the highest frequency? Highest running speed? Others can also answer it. Others can also answer it. Can anybody tell me? Okay, let me begin. Can class अभी भी और 15 मिनट चलेगा. Can you tell me ceiling fan का RPM कितना होता? All question is meant for everyone. Everyone. You have ceiling fan? Now don't tell me you have never seen a ceiling fan. Okay. Have you noted one thing? Have you seen a ceiling fan in TV or video? Vinith,
Yes, sir.
have you seen a peculiar thing that ceiling
Yeah.
fan is rotating in opposite direction when you see it in video? और
Yes, sir.
घर के अंदर भी कभी कभी ऐसा होता है. Have you seen it? Ever seen it?
Yes, sir.
वो क्या इफेक्ट है? You know that?
So basically like frames per
Aliasing
second of
effect.
the
No,
camera.
that is stroboscopic aliasing effect. You should know all this thing. You can't become an engineer simply, studying ordinary subject like thermodynamics or machine design. You have to look for answer in each and everything. That is called aliasing effect or stroboscopic effect. You should learn it. Anyway, घर का सीलिंग फैन का आरपीएम कितना होता कौन बताएगा?
Sir, around 220 to 300.
किसने बोला?
Nitesh.
शादीशुदा हो?
No, sir.
You are almost correct. It is around 300. Anyway, now I'm coming back to Richa's question that a ceiling fan has to rotate at 300 and this may be 30 RPM, 50 RPM. तो पंखा 50 RPM में घूमेगा तो हवा मिलेगा कहाँ से?
Yes, sir.
No. So how do you solve it as an engineer? See, how do you solve it as an engineer? If I am the engineer, what I will do, I will say, no, why 600? I'll go to 800. Because my fan, of course, ceiling fan doesn't rotate at 800, but some other machine, perhaps I may not work with 600 RPM. I may require 800 RPM. So can I tell my manager that no, don't run the pump at 800 RPM because vibration will be large? So what do I have to do? I'm an engineer. I'm earning large salary for it. I will go for balancing. I'll reduce the denominator here, ME. Okay,
Yes.
so I'll go for balancing. And that is why I will be paid. Remember? So I will go for balancing. I'll reduce the unbalance. And if I can reduce the unbalance, my machine can now go even at a higher speed. So the first answer, in a ceiling fan, can anybody tell me why unbalance comes? Because there are 3 blades. All the 3 blades, even if they are manufactured by similar procedure, may not have same mass and same center of gravity. So a ceiling fan unbalance is very, very common, very, very common. And you will see some old ceiling fans that they dance sidewise. It means it has unbalance. So if the fan has unbalance, I simply cannot say that it cannot rotate at 600 RPM, let it rotate at 30 RPM, 50 RPM. Okay, so RPM, even if from this problem, even if RPM, lower RPM can be far better as far as vibration is concerned, but it may not serve my purpose. So have I answered your question? Still have a doubt?
No, sir, I got it.
Now, Now you try to answer another question that yes, RPM. So let me try to connect, this theoretical problem with Alka Savarkar ki? পরে কথা বলবো ঠিক আছে পরে so let me connect this problem with our day-to-day life. So I agree. So with this graph, will you agree that a lower RPM is always better than higher RPM? I accept, but a lower RPM doesn't mean that I can go for a ceiling fan with 50 RPM. It also means that I have to be very, very careful with high RPM machines. Because for high RPM machines, I can never bring my vibration level below 1. Agree? For low RPM machines, I can make it much, much below 1. But high RPM machines, I cannot make it less than 1. So for all machines which run at high RPM, I have to be very, very careful. In this background, I am asking all of you, what is the highest RPM machine in our house, in everybody's house? Ceiling fan is 1, RPM is around 250, 300, agree. But there is something else which rotates at higher speed. What is that?
Submersible pump.
हाँ? अरे घर का अंदर सबमर्सिबल पंप घर का अंदर नहीं रहते हैं।
सर वॉशिंग मशीन।
हाँ?
वॉशिंग मशीन।
किसने बोला?
प्रसाद।
करेक्ट। और एक इक्विपमेंट का नाम बोलो। गर्ल्स शुड पॉइंट आउट दैट सेकंड इक्विपमेंट।
वाटर पंप सर।
हाँ?
वाटर पंप। ग्राइंडर।
नहीं, very common equipment I am saying.
ग्राइंडर।
सर
क्या?
वाटर मीटर।
No. Somebody said it. Mixer grinder. You are correct. Mixer grinder. So please find out what is the RPM of mixer grinder and what is the RPM of washing machine. They are much, much higher speed. इसके आगे भी हायर स्पीड इक्विपमेंट सबके घर में नहीं हो सकते हैं, बट we use saving automatic saver, electric saving machine. Okay, they run at much, much higher speed. So RPM is a big thing, big problem, let me tell you, because if RPM is higher, it will be difficult to bring down the vibration level. I cannot ask the RPM to be low. ठीक है? तो नेक्स्ट क्वेश्चन में हम नहीं जाएंगे, 4 नंबर क्वेश्चन हम नेक्स्ट डे लेंगे, लेकिन लेट मी शो यू ए वीडियो. आज इससे आगे हम नहीं बढ़ेंगे, बट लेट मी फिनिश विथ ए वीडियो. बट आवर नेक्स्ट क्लास ऑल्सो विल बी प्रॉब्लम सॉल्विंग क्लास, एंड दैट विल बी टुमारो आफ्टरनून. टाइमिंग you will tell me. So can I schedule it 4 o'clock? MTech students, BTech students, they are free, I know. It will be problem solving only. ठीक है? We have, ये कल का जो क्लास मिस हुआ, that tomorrow tentatively at 4 o'clock and it will be problem solving only. So I'll end up with a video. Let me see if I have the video or not. Can you see it? सबको दिखाई दे रहा वीडियो?
Yes, sir.
देखो 3 मिनट, फिर मैं सवाल पूछूंगा. You just see it. By the by, can you guess? Can you guess what is this video about? Hmm? अरे
Vibration comes with earthquake.
no. Video is about earthquake that happened in Nepal. Okay, and during earthquake, what happens? Because many a times we can't capture, but in whatever you have seen, what is the interesting thing? Have you noted? I know most of you were looking at the road. Other than road, anything else have you seen? ये जो कॉलम है इसको हिलता हुआ देखा क्या? नहीं देखा. ये जो वायर है वायर को हिलता हुआ देखा. आई विल रिपीट इट एंड जस्ट सी. The large vibration occurs on this wire, and this vertical column is also vibrating. You can see it. Vertical column is also vibrating. Wire is also vibrating. But after 2 minutes, something interesting will happen. Did you see this thing or you didn't see? Let me see. How? So this is interesting thing. Now you see. That is going to happen in another 10 seconds. What did you see? अरे कुछ नहीं देखा क्या? What did you see here?
That the thing above the statue is
And
collapsed.
yeah, this four column structure, it collapsed. Statue did not collapse. ऐसा क्यों हुआ? So earthquake is a peculiar thing. We'll discuss after 1 month. What is the beauty in earthquake is that it doesn't damage everything. Okay, so here you see that the statue did not fall down, but the 4-column umbrella structure, it collapsed. And fortunately, both these cars or automobiles, they got saved anyway. So these things we'll discuss during earthquake. So this subject is very, very interesting. Earthquake will come. Earthquake is not related to today's discussion, but I thought that let me show this video today. तो ठीक है, आज का क्लास हो गया. Let me take out the video. हाँ, किसी को लास्ट मोमेंट में कोई डाउट है तो बोलो, अदरवाइज we will meet tomorrow 4 o'clock. कुछ डाउट है, कुछ प्रॉब्लम आ रहा तो बोलो. अभी धीरे धीरे स्पीड बढ़ाएंगे हम, ठीक है. आई एम हैविंग दिस प्रॉब्लम सॉल्विंग सो दैट यू आर स्टिल बिगिनिंग. प्रॉब्लम सॉल्व, you may find the problems difficult, but after tomorrow's problem solving class, then it will be mostly theory. Problem I will not solve. I will give you the problem sheet, but I will not solve as I have done today. Any other problem you are facing? Any suggestion? किसी को कुछ बोलना है तो बोलो.
So about MATLAB, so VNIT provides us license, so like we also get online access to.
I know.
So can we use that?
No, I know VNIT already. VNIT is officially connected with MATLAB.
So like online version we can use, right?
You can. So, but how to get it? I don't know. So that you have to find out who is the coordinator. MATLAB coordinator.
I've sir already done it.
But you have done it fine. I mean, let everybody have online.
Okay.
Okay. But as far as vibration is needed, we will not use it too much. For whatever we need it vibration, even if you have a third party copy, no problem. But you have it quickly so that I want you to write down the tomorrow. Then can we have the rather than problem solving, can we have the programming simulation if you all are ready with MATLAB? Can I presume by tomorrow you will have more or less MATLAB ready with you? किसके पास नहीं है हाथ? MATLAB ready, अगर ready है तो कल हम MATLAB का थोड़ा प्रैक्टिस करेंगे. चलो प्रॉब्लम सॉल्विंग भी करेंगे, MATLAB का भी प्रैक्टिस करेंगे. ठीक है?
hello,
You
sir.
may be a beginner. हाँ बोलो.
Sir, which products we have to install? Like I have just installed MATLAB and Simulink. So anything
चलेगा,
else?
Simulink both, it will take time. Only MATLAB also I will do. You should know when you start your MATLAB, two windows will come up.
Yes, sir.
वो हो रहा है कि नहीं? One is command prompt window, the
Yes,
other
sir.
one is script file window. दो विंडो आएगा, देखना. एक कम I will show it tomorrow. नहीं मैं I cannot run MATLAB on this PC, इसमें लोड नहीं है. But those who know MATLAB, it takes time. MATLAB takes time, but once MATLAB opens up in your computer, you will see there are two windows coming up. One window we call it workspace or command prompt. Means whatever I am doing now, it will appear. All my interaction with MATLAB will appear in command prompt. But in script file, I can write the program and I can store, I can run. That I can do in the script file window. But my answers, my inputs, everything will be in the basic window, that is command prompt window. ठीक है? तो उसके बारे हम चर्चा करेंगे, कल ही करेंगे. चलो कल मिलते हैं 4 बजे. You can leave now. It is lunch time. It's lunch time, so have a good day. Tomorrow we'll meet. You can leave now.